Okay, so we're going to do the baking soda and vinegar stoichiometry lab. The purpose is to predict the amount of carbon dioxide gas that should be produced in a chemical reaction, which is your theoretical yield. Then calculate the amount of carbon dioxide released and the percent yield. So what we are releasing, we're going to find our actual yield. So we're going to use baking soda and vinegar, and we're going to create sodium acetate, water, and carbon dioxide. And that's all in on your little lab sheet here. The materials we're going to use is baking soda, vinegar, and 2 beakers and electronic balance. Okay. So first thing we're going to do is we're going to get the mass of an empty beaker, Beaker A, and that is 106.84. 6.84 grams. Okay. Then it says, with the beaker still on the balance, add approximately 10 grams. And it doesn't matter if we're exact, so we need to be about 116. Just a little bit. If it goes over, it's okay. We're just going to record what we have. All right. So now we're at 116.53. And we're going to put that in part 2 of our lab sheet. 116.53 grams. Okay. All right. I'm going to let you do number 3 by yourself. It tells you what to do. We're going to get the mass of Beaker B empty. We do want to make sure our balance is clean and zeroed out. All right, so we're at 102.55. And that's number 4 on your sheet. 102.55 grams. Okay. Now we're gonna, it says place Beaker B on the scale, weigh and record approximately 50 grams of vinegar. The mass does not have to be exact as long as you record the mass accurately. So we're going to try to get 50 grams of vinegar. Oh, I might have gotten it almost correct. Okay, so that's approximately 50 grams. Yeah. So the mass of the vinegar and the Beaker B is 155.14, and that goes on number 5. Okay, I'm going to let you guys figure out number 6 by yourself. I'm sorry, take that back. Number 7 is what you're going to calculate for yourself. So basically, number 3 and number 7 are how much we actually have in our beakers. Okay? My goggles are fogging up again. I got just enough mask on to fog it up and I can't see. Okay, so Mr. Broderick, you wanna, because my goggles are fogging.
Okay. Okay, so it says, now we're going to slowly add the vinegar to cup A until the reaction is stopped. Okay, so get that out there where you can see.
And you do want to do this slowly.
Okay, and so we're going to just slowly, and you see that it's fizzing up.
Now we don't want to add all the vinegar.
And we got to see if we still got some baking soda left in there. And there's still a little baking soda left in there. And you will know that the reaction is complete when we add the vinegar and we no longer get any bubbles.
you definitely don't want to use up all the vinegar. Let's stir it around a little bit and see if we can. Because we're almost out of vinegar. That's probably,
I don't see any more reaction.
I don't see any more reaction either.
I think we're done there. Okay. So now we need to record the mass after the reaction. Okay, this is number 6, and it's
108.84 grams. Number 7 you're calculating for yourself. And now we want mass of Beaker A after reaction. It looks like 161.18 grams.
Okay.
Okay, so now the rest of this activity you are going to do by yourself. So let's give you some heads up. All of the numbers 9, 10, 11 will tell you what to do mathematically. Okay, so you're just going to do that information and give us the data. When you go to the back side, okay, it says what are the reactants in this experiment? Well, what did we start with? So I'm going to go ahead and help you out. We started with baking soda. And we started with vinegar. Now you can also put down the formulas for this. So if you look here, that's vinegar, that's baking soda. So we started with NaHCO3 and, I always forget vinegar, CH3. COOH. I ran out of room. So you can put either one of these. Now what are the products? Well, if you go back to your formula, your equation, it's at the top. Just start writing them in. Which one ran out first? Which one did we run out of? That's the limiting reactant. Which one did we have the most of left over? Think about it. We had some left over. We ran out of, okay? I'm sorry, did you get that? Okay. Using stoichiometry, calculate the theoretical yield of carbon dioxide. Well, a theoretical yield is what we're trying to get to. So, when you're doing your stoichiometry, you're going to go from, and you don't have to write this down, but we are going to go from baking soda, that's our given, to our question mark, our unknown, which is carbon dioxide, CO2, in grams to grams. So you're going to need 4 tracks. Okay? What is your percent yield? Remember, that's actual yield, which is what we did in the experiment. How much did we get? Over our theoretical, which is what we're going to find out here, times 100. Now, percent error we haven't really talked about, but the equation is on the front. It says percent error, actual yield minus theoretical yield divided by theoretical yield times 100. You will get a negative number. If we did not get a negative number, then we had a contamination and our experiment failed. So just keep that in mind. You should have a negative number. And then here, matter cannot be created or destroyed in this reaction, yes or no? Explain your answer. We've already talked about conservation of mass, conservation of matter. So does this apply, yes or no? And then explain. That means you need to have a complete sentence, a complete thought, okay? If you have any questions, please ask your teacher. And that concludes this video.